Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we'll be looking at how you can calculate arc length using radians. Calculating arc lengths. So let's say you had a circle with radius r, where this angle in the center is theta, and the length of the arc is L. Now, similar to what we did in the last lesson, if we look at what fraction of the circle we have, in terms of the circumference, the fraction that we have is L out of the whole circumference. So that is L out of 2 pi r. In terms of the angle, what we have is theta out of the complete turn at the center of the circle, which is 2 pi radians. So these proportions must be the same. L over 2 pi r must equal theta over 2 pi. That gives us 2 pi times by L is equal to 2 pi r theta. And dividing by 2 pi gives us L equals r theta, which is a surprisingly simple formula for working out how long an arc is. So as long as you're measuring theta in radians, the length of an arc of a circle is just given by the radius of the circle times by the angle at the center, theta. Okay, let's have a look at how this works out in practice. So example 1, calculate the length L in the following diagram where the angle is measured in radians. Now there are no tricks, no catches in this. I'll let you have a go at it yourself first. Pause the video, come back to me when you're ready. Okay, let's have a look. So we just use the formula, L equals r theta. We know what r is, we know what theta is. We just substitute them in. So the length of the arc is 4.8 times 0.5. The length of the arc will be 2.4 centimeters. Example 2, given a sector of a circle with arc length 5 and radius 8, find the angle subtended at the center of the circle. Now you don't really need to do a sketch for this question, but I suggest you do. And then have a go at answering it. So pause the video, come back to me when you're ready. I would always do a sketch on these questions, just because it normally doesn't take much time at all, and it does clarify things just in case there is any catch. Now, in this question, there is no catch. So we've got a circle with arc length 5, radius 8. We've been asked to find the angle at the center. We are just using the formula in the normal way. So L equals r theta. We substitute in the two values that we know, which in this case are that the length of the arc is 5 and the radius is 8. That'll give us that. That gives us theta is 5 divided by 8. You could leave that as a fraction, or you could write it as a decimal. 0.625 radians. Okay, a slightly harder question. A lawn is the black outlined shape below, where the curved side is the arc of a circle with radius 5. Find the lawn's perimeter. So what we're looking for is the total distance around the outside. We already know that this is 4, so we just need to find the curved length of the arc around the outside there. To do that, we need to know the value of theta here. We don't know that, but we can work out the value of the angle in this triangle. Then we can work out theta. Okay, I'll let you have a go at doing all of that yourself first. So pause the video, have a go, and come back to me again when you're ready. Okay, let's have a look at this. The only problem in this question is working out the value of theta, and as we said, the easiest way to do that is just by focusing on this triangle AOB. Well, that's the triangle AOB, and we know that this length is 5, this length is 2. It's an isosceles triangle, so if we draw a perpendicular down to AB, it will bisect AB. So this side will be 2, this side will be 2. And then we can find the little angle x here by using trigonometry. Opposite over hypotenuse will be 2 divided by 5, which is 0.4. So the sine of that angle will be 0.4, which means that x is equal to 0.4115 radians. Do make sure you're careful with your calculator. on these questions. Make sure that it is set to radians and not to degrees. That means the whole of the angle at the top of that triangle, the angle AOB, that must equal double that, which is 0.823 radians. That's this angle inside the triangle here, which means we can now work out theta. In degrees, it would be 360, take away that. In radians, it's 2 pi radians, take away that, which gives us 5.46 radians. Okay, now we know the value of theta here, the large angle, the reflex angle on the outside, which means we can work out the length of the arc, the major arc, from A to B. And you still just use the formula in the normal way. It'll be r times by theta. The radius is 5, theta is 5.46. Multiply those together, and you get 27.3 meters. So that's the curved distance from A to B around the major arc. We need to add 4 onto that to get the total perimeter for the lawn, and that will give us 31.3 meters to 3 significant figures. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 137 and have a go at exercise 7B. Thank you very much for listening, and cheerio.